Hello, everyone, and welcome to ROKStudios. I'm Stan Miller. I'm PR and Analyst Relations Manager for Rockwell Automation in the EMEA region, and I'm joined today by Pavel Matejka. He is EMEA Product Manager for Micro PLC and Distributed I/O for Rockwell. Pavel, welcome to the studio.
Good afternoon. Thank you very much, Stan.
Pavel, we're here today to talk about the next generation of I/O technology. Interesting topic, and as you're an expert in it, let me ask you, how is the evolution of remote I/O systems reshaping the way manufacturers approach system architecture and machine design?
Yes, machine designers really insist on having perfect control systems. The system must be perfect from the beginning to the end. And when they say we need a perfect control system, that also means they need perfect parts, perfect components, perfect platforms. And here it's when distributed I/O, also called remote I/O, come to place, because they really simplify the design, and this way they simplify the life of the machine designers, because they allow them to save a lot of effort associated with design by just applying this relatively simple automation platform. So if you imagine a practical situation, we have a machine with a conveyor belt, maybe 10, 15 meters long. We have a control cabinet with a controller on one side. And we have a whole bunch of sensors monitoring maybe bottles where they are not falling from the conveyor. And we need to connect those two. And each sensor needs 2 or 3 wires. So if we have 20, 30 sensors on one side, we would need to bring many wires from one side, 10, 15 meters to the controller, which is absolutely impractical. And that's how traditional centralized systems used to be designed. With modern systems, designers apply distributed I/O, also called remote I/O. So that means that the wires are very short, just few centimeters, maybe dozens of centimeters. The information gets collected at the end of the conveyor inside the distributed I/O platform. And then there is just one cable, one Ethernet cable brought from that remote location to the central cabinet, to the controller. That saves design efforts, design energy tremendously.
Great example of simplification, which I think OEMs in particular can appreciate. Let me ask you this. In what ways can flexible I/O technology help manufacturers address the growing complexity and variability of modern production environments?
Well, there are many aspects. The first one I would like to mention would be probably cost reduction. And it's not only the cost of to acquire the equipment, it's the total cost of ownership. And that's where exactly distributed I/O come to place, because their cost to acquire is relatively low. The operation cost is extremely low, and also the cost to replace when something goes wrong, something breaks, is very, very low. That's a big difference versus the traditional concepts of centralized systems. So for instance, if something happens and one card dies, users do not need to replace the whole block. They just replace just one card, and this really decreases the total cost of ownership. The second point I would like to mention would be certainly reduction of downtime. That's an extremely sensitive subject among machine builders. Every minute of downtime costs a lot of money these days. So the primary effort is to avoid downtime at all costs. And second, if or should downtime happen or occur, we need to be able to start the machine in full speed as soon as possible. Here, again, there is a big benefit brought by distributed I/O, because they provide a lot of diagnostics to the controller. So we can receive valuable information, what's happening with the control technology, what's happening with the control system. And this way we can predict whether there will or will not be any problems. Many users still use just the traditional diagnostics, like a status light, okay, not okay, or a broken wire detection. Modern control systems offer many more diagnostics. Let me give you one example, and that's timestamping. So when something happens, an event occurs, the distributed I/O block assigns a precise timestamp in terms of microseconds and sends the information to the controller. So the controller not only knows what happened, but also when exactly that happened. And the third important aspect would be increased efficiency. Distributed I/O allow designers and also machines as such to simplify the process. That means the stream of data flowing through the system just collect data from 30 different sensors, as mentioned in previous example, and send the data in once to the controller. That's a big simplification, and that adds a lot of value to machine designers and machine builders as such.
Excellent, Pavel. Share with us, what role does real-time communication and system integration play in enabling smarter, more autonomous industrial operations?
Stan, imagine the answer can be just one word, and that word is data. To be more specific, it's data and all processes associated with data handling. So when it comes to our modern control systems, the first is the real-time data acquisition. So we collect data from our technology in real time. We receive the data into our distributed I/O, and then we are able to share the data in real time through the control system to all parts of control system that need to receive the data. Traditionally, it used to be just one controller, so we send the data to the controller. Now we have systems with many controllers, so we want all controllers to receive the data at the same time. That's very well possible. And obviously with modern technologies, we want to send the data also to clouds. So cloud connectivity would be another part of real data traveling. Once we have the data inside the system, inside the controller, there comes the third part, and that's the data-driven decision making. So the control system, based on the input data, decides what needs to happen with the technology, and then sends the output again back to the distributed I/O to write the control information back to the technology.
Interesting. My last question for you, help us understand, as industrial environments become more compact and interconnected, what are the key considerations for designing resilient and future-ready automation systems?
First of all, it's flexibility and scalability. In other words, imagine again a machine builder producing multiple machines which differ but by just few signals. So you need maybe an extra input card or an extra safety I/O card. Other than that, the system is the same. So scalability means that users do not need to use a different I/O platform or a different controller. They just scale their system by adding one or two extra I/O cards, which leads to significant simplification. It also brings a lot of savings on stocking because machine builders stock the same parts for all machines, and that also simplifies maintenance because all machines are pretty much the same. Second point I would like to mention is associated with robust cybersecurity, which is a hot topic or has been a hot topic for many years. Historically, cybersecurity was solely associated with IT. That means personal computers, high-end routers, switches. Now, obviously, also our low-end automation devices need to be robust. They need to be cyber resilient. So specifically when it comes to distributed I/O, then the biggest threats coming are correct response to unsolicited messages. So somebody connects to the network, starts bombarding our devices with data. Second, many devices are equipped with web servers. They need to be protected. That's also typically a weak part or weaker part inside the design. And then the distributed I/O devices need to be resilient against wireless connections. So somebody comes and tries to connect via Wi-Fi or Bluetooth or NFC. they need to be able to maintain or manage access just for the allowed people, not for external threats.
Pavel, you've shared a lot of best practice and given us a roadmap of where this technology is going and how it's evolving. But could you share with us, give us some detail on a Rockwell Automation example that kind of embodies some of these technologies that are connecting back up to these larger trends? Could you share a little something with us?
Let me mention the top two. Number one would be our brand new PointMax IO platform. And that has been designed exactly in mind with the aspects we have been talking about. So it's simplicity, it's the speed, it's super fast, and it's also small. So it fits the needs of modern machine design. And it's an in-cabinet platform, so it's intended to be used in a control cabinet. The second platform I would like to mention at this point is our offering of I/O, which are intended to be mounted directly on machine, and that's our ArmorBlock 5000 platform, which perfectly fits all these on-machine requirements.
Excellent. Pavel, it's really great to get your insight into this technology, how it's evolving, and how it's meeting machine builder needs. Thank you so much for joining us in the studio today.
It was a pleasure for me. Thank you very much for having me today.
And thank you for watching. If you'd like to learn more about industrial automation and digital transformation, visit rockwellautomation.com.